Hi, welcome to RAR Math. Today I'm doing a series of videos on variation. In this video, we have the question, the maximum load M of a horizontal beam that is supported at both ends varies jointly as the width of the beam and the square of its height, and inversely as the length between the supporters. Okay, so a beam is 6 meters long, so the length is 6. 0.1 meters wide, so the width is 0.1, and 0.06 and 0.06 meters height. So the height is 0.06 and supports a load, so the maximum load is 360 kilograms. With this many variables, I think it's easier to assign the numbers to the variables. Then we have, if I come back and I start over, it says the maximum load M of a horizontal beam that is supported at both ends varies jointly. Again, varies jointly means direct variation with more than one variable. So varies jointly is K times, because K is our variable of proportionality, constant of proportionality. So varies jointly with the width of the beam and the square of the height. So height squared. Make sure you read this really closely because square and square root often gets confused. And inversely is when we divide our variable of proportion, our constant of proportionality. So we have to do both. So it's a combined variation because we have both direct and inverse as the length. Well, we have numbers, we have a base formula. We can now substitute everything in. M is 360, K is what we're solving for, W is 0.1, H is 0.06, and L is 6. All right, I could go ahead and multiply 0.1 times 0.06 squared divided by 6. I'm going to get like this hugely tiny number because when you have small numbers divided by big numbers, they become smaller. I'm just going to actually multiply both sides by 6 divided by 0.1 divided by 0.06 squared. 0.1, 0.06 squared. Sorry, I should have left more room. This should all be 6. 6 divided by 0.1 times 0.06 squared times the 1 that is down there. So when I calculate K, I'm going to rewrite this so it makes sense. It's going to be 6 times 360 divided by 0.1 times 0.06 squared. This is what I'm going to put in the calculator. Make sure when you put this into your calculator, you either put an extra set of parentheses around that denominator, or you do divide 0.1, divide 0.06 squared. When you get K should equal 6 million. When you take big numbers and divide by small numbers, you get a really, really big number. So our final equation is our maximum load is 6 million. A little more space. WH squared divided by L. We just have room on our paper for that. Okay, so that is our maximum load. Whew-da. What is the maximum load supported by a beam 16 meters long, 0.2 meters wide, and 0.08 meters high? So 16 meters long, L is 16, W is 0.2, and H is 0.08. We're using this formula we had up here, and this time we're solving for M because we already have K. We do the first part to figure out our K, and then we use that formula for all the subsequent problems. M is equal to 6 million. W is 0.2. H is 0.08 squared. And we're dividing that by 16. This is a bit simpler to put into our calculator because there's only one number in the denominator. We throw that all into our calculator, and we get that M is 480 kilograms. Now, I don't put labels in any of the work. It's already pretty complicated as it is, but I get all of my labels up from the original problem. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, and I'll see you on the next video. Thanks.